Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, which is video number 3 on momentum, we will continuing a study the concept coalesce. And coalesce mean when two bodies collide, they combine together after that, right? So we will study those type of cases. I have taken 2 examples here. And here are the QR codes of all the videos I have made on P3, S2 and M1. You can scan these codes to watch more videos. And it is a part of the syllabus of A-level mathematics M1. So let's see first of all what is coalesce. Like I said in a simple words, when bodies are colliding and after that they move together as they are one object, right? Rather than getting separate, they are together. They become single object. So an example of this type, if you are taking, what does it mean? Railway truck being pushed up by an engine or person jumping onto a moving vehicle. So we are taking here real life example which are in context of coalescence. And the opposite of this is called explosion, which means when they get separated. For example, engine and truck become decoupled, person jumps off the vehicle. So these type of cases. So let's see here the example. A body of mass 5 kg. By the way, like I said in the previous video, after reading the question, I always put it in the diagram form. It's easy to understand. And I would recommend the same to you. You also do the same thing. A body of mass 5 kg. So I have drawn here. Let me use some other color. So I have drawn here this circle 5 kg is traveling with velocity 6 meters per second. It catches up and collides with a body B of mass 3 kg which is traveling along the same line, and that is the reason I have drawn both the direct arrows in the same direction. So this is the information I have taken from the question. This is before collision. Now after collision, what happened? The bodies merge with a single body. So that's why I have drawn here the diagram which is showing that both the bodies are together now. Find the velocity after collision. So I have to find out this velocity. So we will apply here the total momentum before collision equals to total momentum after collision. What is this? Law of conservation of momentum. So let's say start before. It is MAUA plus MBUB, right? I'm talking about these. This will be equals to M. Now this time A and B are together and it is V which is together. So in this case the mass is 5 times 6 plus 3 times 4. And this is together it is 8 and velocity we don't know, we have to find out. So 6 5s are 30, 4 3s are 12. Okay, is equals to 8 VB. 42 divided by 8. So what is this? Let me just take it in the calculator quickly. 42 divided by 8. So it is 5.25 meter per second. So you can say velocity of the combined bodies is 5.25 meter per second. Right now I have taken very simple example just to build the concept. In the next video onward, I will start taking past paper questions because building of the concept is very important initially, right? Now the second example, a block of mass. Now by the way, if you want to put the video on pause and try to solve it yourself, it would be wonderful. Else I have solved here, I'll explain here as well. So a body of mass 200 gram. Now be careful, it is given in gram and you have to change it into kilogram because the unit of the momentum is kilogram meter per second or Newton second. And we have seen the reason also in video 1. So 200 gram moving with 4 meter per second. So here, just like I said earlier, draw the diagram and write it down, the important information. And makes a direct collision with a larger block of mass 500 gram moving at 1 meter per second, right? And it is written here Part A, they are taking two conditions here. One condition is when they are moving toward each other. So just focus on part A right now. So information here and arrows I have taken in the opposite direction because part A is saying they are moving in the opposite direction. Okay. Find the speed of the block after the collision if the blocks were initially moving toward each other, right? So now what will happen? See here, after. Again, if you want to read the question, see here. On impact, the block coalesce. It is given to you that in both the cases, part A and part B, you will consider that after the collision, the bodies are acting as a single object, right? And that is the reason we have written it like this. So now we have to find out what? The velocity of this object. So just like in the previous case, we have written the values. So we will just substitute the values here, okay? And because it is in the opposite direction, so that's why I will take here negative value. And then simple algebraic manipulation, you will solve it and get the answer. Final answer we usually write in 3 significant figure. So it is 0.429. Now the question is same, the information of the mass and everything is same, but what happened now? In part B, it is talking about find the speed of the blocks after the collision if the blocks were initially moving in the same direction. So now initially they are moving in the same direction. Here. In part A, they were moving toward each other, but now they are moving in the same direction. So now what will happen? They will also coalesce according to the condition. So now again we will apply law of conservation of momentum, right? And substitute the values here. The impact will be that now one will be positive because it is in the same direction. Okay, I hope you're understanding. I have tried to draw diagram very clearly so that it can make sense to you. Now simple calculation. And then final answer in 3 significant figure, which is 1.86 meter per second. So now in next video onward, I will take past paper questions, which are a little tricky. So, and there are 3 bodies also. And then on the ramp also. So we will consider all those in one by one in different videos. So please press like and subscribe button.